Chapter 6, Section 2. In this section, we're going to learn how to determine whether a function is one-to-one and how to determine the inverse of a function defined by a map or set of ordered pairs, and how to obtain the graph of inverse function from graph of the function. And last one, we are going to learn how to find the inverse of a function defined by equation. So first topic, we talk about how to determine whether a function is one-to-one. So in order to be a one-to-one function, okay, first of all, it must be a function, right? So remember how to determine whether it's a function is every element in the domain pairs exactly one element in the range, right? If this is a x1, this is a y1, and then x2 until xn, this is a y2 until yn. So at that time we say we don't care, whether the y is repeated value or not, okay? But this time, one-to-one function is a function, and at the same time we have to make sure the two different inputs in the domain corresponds to two different output in the range. So in other words, both directions need to pair exactly one with one. All right, so x1 cannot equals x2, okay, two different input, and then f of x1 cannot equals f of x2. So the y is also two different values. All right, so from the map, you will see every element, okay, pairs exactly one y, and then every y pairs with exactly one x. Okay, this kind of map is one-to-one function. Okay, so this is a one-to-one function. So let's look at another one. So left-hand side, every element only pair with one y, but from right-hand side, every one y not pair just one x. Okay, for example, 11 pairs with two x, dog and cats, right? For this one y pairs with three x. So this is not a one-to-one function. But it's a function though, okay, just not a one-to-one function. All right, so definition of one-to-one function. A function is one-to-one if any two different inputs in the domain correspond to two different outputs in a range. That is, x1, x2 are different inputs, and then function is a one-to-one if the y are different outputs. So from this map, okay, we can see one-to-one function is the most restricted because both direction is restricted, only pair with one, okay? And then the B, that is a map for a function, is less restricted. It only, defines x, different x must pair with only one y, but we don't care whether one y pair with just one x or not. Okay, so the B represents a function. And then the C, this is just a relation, not a function. And then since it's not a function, of course, it won't be one-to-one function. Okay, so this map from left-hand side to right-hand side is restrictions are more loose. Okay, and then from right to the left, the restriction is more and more restricted. So now let's look at an example. Okay, another example. Determine whether the following functions are one-to-one. So first, it is a function, but it's not a one-to-one function, right? Because one y paired with two different x. So A is not. If given the order pair, how to determine whether it's a one-to-one function, we have to check x, whether it have repeated value, and then check y, whether it have a repeated value. If both x, y have no repeated value, and then it's a one-to-one function. All right, let's see. Let's check x first. -2, -1, 0, 1, 2, all distinct values. Let's check the y. Okay, 6, 3, 2, 5, 8, all distinct values. So this is a one-to-one function. And then in order to check whether, the graph of a function is a one-to-one, okay, we use horizontal line testing method. Okay, but again, remember the precondition, it must be a graph of a function first, okay, and then we use horizontal line testing method. Checking whether graph is a function or not, we use the vertical line testing method. Remember? Vertical line test. And then if we already know it's a graph of a function, and then we use a horizontal line testing method to check whether it's a one-to-one function. Okay, let's look at an example. All right, if this is a given graph of a function, and then we draw any horizontal line and see how many intercepts, okay, the graph with the horizontal line. If just one intercept, and then it's a one-to-one function. If more than one intercept, it's not a one-to-one function. Okay, so let's try. Draw a horizontal line here, okay? Draw a horizontal line anywhere. 2 intercepts. So this is not a one-to-one function, but it is a function though. All right, and then next example, use horizontal line test to see whether the function is one-to-one. So we already know those are already a function. Okay, so all we need to check is whether it's past horizontal line testing or not. So square function we know is a parabola, right? And then if you draw a horizontal line, 2x-intercept, so this is not a one-to-one function. Okay, cube function. We know the cube function is this kind of graph. If you draw a horizontal line, okay, anywhere, only one intercept, so this is a one-to-one function. All right, you can see a better graph. Parabola is not a one-to-one function. Cube function, it is a one-to-one function. And then we introduce a theorem, okay? A function that is increasing on the interval, okay, and then on this interval, it must be a one-to-one function. And it's similar for the decreasing, okay? So what does theorem tell us? Okay, if a function is a monotone, okay, either increasing or either decreasing, and then on this interval, right, increasing or decreasing, and then we say on that interval, function must be one-to-one.